99% of people solve this problem the hard way, but this entire leetcode problem works because of one hidden trick. A number becomes common on its second appearance. Want full solution? Check this video.
Hi everyone and welcome back. Most people overcomplicate this leetcode problem, but the entire solution depends on just one observation. Today we are solving the leetcode problem. Find the prefix common array of two arrays. And this is one of those problems that looks complicated at first, but once you spot the pattern, the code becomes incredibly simple. So let's understand the problem. We are given two arrays, A and P. Both arrays are permutations from 1 to n. And for every index I, we need to calculate how many numbers are common between A from 0 to I and P also from 0 to I. And we need to store that value in the answer array. So let's walk through an example. So imagine that we have two arrays. Let's use this one from example 1. So we have array A and B. A equal 1, 3, 2, 4 and B contains the element 3, 1, 2, 4. So at index 0, A prefix is just 1 and the B prefix is just number 3. So this at I equal 0. So no common number yet. So the answer still 0. The answer at I equal 0. And again at index I equal 1, the A prefix equal the two numbers 1 and 3, and the B prefix array equal the number 3 and 1. And as you can see here, now both 1 and 3 exist in both prefixes. So the answer now is at I equal 2. And we continue the same strategy for the rest of the array. The key observation here is that a number becomes common the moment we see it for the second time overall. Why? Because first time means it appears in only one array, and the second time it means it now appeared in both arrays. And that means we don't actually need frequency counts. We only need to know, have I seen this number before or not? So to solve this problem, we will need a Boolean array. Let's call it seen. And this will be of the size n or n plus 1 because the numbers are from 1 to n. And we will use this array to check if we have seen that number before or not. This array is initialized its element to false, and then for every index I, first we process A of I, and if we already saw it before, that means it now exists in both arrays. So we increase our common count. Let's imagine that or assume that we have here a variable that's called common count initialized to 0, and we first process the a prefix array, and if we have seen this element at the index I before, we will increment the common count, and then we will do the same for the b prefix array, and also if this number is seen before, we will increment our common count, and finally this will be the answer at that index. If you still didn't get it, let's dry run it quickly. So suppose again that we still have our a and p array, and our common count is initialized first to 0 and our index is 0. So first we have seen 1 here for the first time, so we will mark that as seen, so we have seen before, and also we have seen the three number at the p array, so we will mark that also as seen. And as you can see, it's seen for the first time, so nothing is changed for our common count, so the answer at index 0 will still 0. And then again for index 1, we have seen 3, but 3 is seen before, so that means that our common count, let's name it common, will equal now 1, and then we process b, we will find the number 1, and 1 is seen before, and that will increment our common to 2. So the answer at index 1 will be 2. And that's exactly what we want. So now let's go through the code. So first we will define or store the size of either a or b. So we will define our variable n equal a dot size, and we will define two arrays. One is called answer, and it's of size n, that will hold the end result, and the other one is the scene array. So we'll define a vector, we name it scene, from of size n plus 1, because a and b both are permutation of n, so it has values from 1 to n, and we will initialize its element to false. And don't forget to define our common count number that is initialized to 0. After that, we will iterate through both arrays. So for int I equals 0 and I is less than n and plus plus I, here we need to check if first we need to process a element. So if scene of a of I is seen before, then we will increment our common count. Otherwise, we will set the scene of a to true. We will do the same for b, so we will need to process the b element the same way. So let's copy and paste it. So if scene of p of I equal true. Again, we will increment our common count. Otherwise, we will set it as seen for the first time. And after that, we will set our answer at that index to the value of the common count. And once we complete processing all the elements, we will return our answer vector. So let's run it and let's submit it. And as you can see, this is a solution for today's problem in terms of time complexity. Time complexity is O of n because we traverse the all elements in the array for a single time once. And in terms of space complexity, it's also O of n because we are defining the scene array or vector. And that's it, a very clean of an solution with a very super important observation. A number becomes common exactly on its second appearance. If this explanation helped you, don't forget to like and subscribe to the channel. And if you want more optimized lead code explanation like this, please watch the next video. Thank you. Bye.